Good morning or afternoon, everyone, and thank you so much for being here today. I'm so excited to talk with you about one of my favorite topics, leveraging ethical AI to revolutionize education. At the heart of it, what this session is really about is thinking through how we can best apply AI to support learners on their journeys to meeting their educational and workforce goals. My name is Kara McWilliams. I lead the AI research labs at ETS in Princeton, New Jersey. In the labs, scientists, user experience experts, engineers, designers, developers, and many other colleagues are working together to transform how we think about the application of AI to education. A little bit about my background. I've been working in educational research for about 15 years, 10 of those in educational technology. I have a PhD in educational research and measurement from Boston College, a master's in curriculum and instruction from the same institution. I was formerly a teacher. I quickly realized that teaching is the hardest profession in the world and ran back to research. But of all of that experience and training, I think that my most salient experience that I bring to leading R&D in AI in the K-12 space is being a mom to 4 boys under the age of 5. Those boys right now, because of the pandemic, are being homeschooled. This gives me a critical firsthand look into the experience of young learners as they engage with digital content and the opportunities that AI affords them. It also offers me the opportunity to build empathy for the learners, for their teachers, for their parents and guardians that are supporting them, and bring all of that insight into the strategy of the AI research labs. Anyone who knows me will tell you that I genuinely believe that AI has the potential to increase access, unlock opportunity, and transform how learners connect with educators and one another. Still, AI remains in its infancy, and we continue to discover what learners and educators need and how to deliver it to them meaningfully and ethically. So over the next 40 minutes, I'd like to think with you about 4 things. First, what is a broad brush look at the context in which we're thinking about AI and K-12 education? Second, dig into 3 of the principles that I think are most salient when conducting R&D in this space: efficacy, efficiency, and equity. Provide a high-level overview of the ETS AI research labs, and provide a bit of an introduction into how we approach AI in education research. And based on the research that we're conducting in the labs, share with you a few best practices that have emerged from our work and suggested pitfalls that you might navigate around when engaging in your own R&D efforts. One of the approaches that I take when I'm conducting research is to engage closely and often with users. I like to ask a lot of questions. And often, when I ask users what comes to mind when they think about AI, they describe some Hollywood version of robots sharing the same environment with human beings. In a lot of the scenarios that they talk me through, the best case, humans and robots are engaging in similar activities and living peacefully among each other. But in the worst case, robots have sort of taken over human activities and rendered the humans obsolete. I enjoy the sharing of these scenarios because I like a good futuristic movie as much as the next person. But the entertainment industry has created these grand stories of omni-powerful AI. But these daunting, uncontrollable beings are so far from where I think AI is. And it has unfortunately created a threatening model in users' minds. I suggest that AI is not threatening and should be embraced rather than feared. Remember, AI is completely controllable. Humans develop it. Humans decide whether it's going to be used, and if it is, how it's going to be used. And humans have the capability to continue to evaluate the use of AI and determine whether we should continue in that way. The controllable nature of AI is why intentional progress in AI is so important. Clear decisions on why we're innovating. Thoughtful development. Why is the activity something we should be automated and for what purpose? And considerations for responsible use. Things like who is building these models? What data are being used? How are models being tested are all critically important. If colleagues in the field can come together and align in some of these areas, we might be able to move away from that threatening mental model of AI and help all users embrace the opportunity that lies ahead. And I do believe opportunity lies ahead. Advances in technology and the data these advances enable, paired with the evolution of the learning sciences, has the potential to revolutionize what we know about how people learn and how we support them in meeting their goals. In some cases, though, the data are so far ahead of the sciences that we need to be careful that we have the evidence to make the claims that we do. So, do we have evidence that certain forms of automated personalization are more effective than others? Sophisticated methods don't always outperform more straightforward approaches. We need to be very careful not to let the technology get so far ahead of the sciences that we lose sight of the research base of our models. Relatedly, one area of K-12 education where AI can be most impactful is around assessment. We know from the current research that point-in-time summative assessments are important to measure what learners know, but embedded formative assessments that provide information on learners about how they engage with learning content, what they understand, how they approach complex activities, all of this provides much greater insight into their unique comprehension, where there are gaps, how to close those gaps, and how to get and keep students engaged on a personalized journey that helps them meet their goals more efficiently. Thirdly, at the end of the day, AI will never render humans obsolete, neither from the perspective of building AI nor applying it to educational contexts. So in our thinking and in our conversations about AI and K-12 education, the users, and when I say users, I mean all users in the value chain, should always be central to our research and to our thinking. Just as users should be central to how AI solutions are developed, it's important that both to build trust and have the most meaningful impact, users are partners in the design and development process. Often, users can feel like AI is something that's being forced on them or done to them. Or in some of my user research, I've learned that users feel like they are nothing more than participants or pawns in a research study, rather than partners in why we're studying what we are, what the outcomes are that we're measuring, and what the methods are that we are following to provide evidence that we're meeting those outcomes. So it's important that we co-design and co-develop for more meaningful impact and to build trust. Considering the context within which we're talking about AI in K-12 education, there are 3 guiding principles that I suggest can help researchers and developers reach their unique North Stars. The first is to always think about AI as assistive and focus on efficiency. The second is to consider how we're measuring efficacy and the methods that we're using to communicate transparently the evidence that results from those studies. And thirdly, developers should always think that cornerstone to their efforts is building for equity. Let's dig in a little bit to what each of these principles really means. The benefits of automated intelligence will never replace the impact of human interaction. However, AI can create opportunities for efficiencies so that human interaction can be more impactful. Often when I'm talking to teachers and I ask them what their needs are to better support their learners, they talk to me about supporting the whole learner and how they have neither the time nor the insight to enable the support that the whole learner might need. So identifying learners' unique cognitive and non-cognitive needs and emerging the pairing of these two needs through insights that can allow teachers to support the whole learner is something that can create efficiencies and meet the needs of teachers. Often when I'm talking to students and I ask them what their needs are, they talk to me about some of the pain points in their learning journey, like not being able to engage fully in their instructional content because of all of the competing demands in their lives. Whether it's helping to support siblings or engaging in after-school activities, there is some point in which they disengage with their learning activities because they feel they're not progressing through them efficiently. AI has the opportunity to target the instructional content, assessment, feedback, and interventions that are being provided such that learners aren't expected to engage in content that they may have already mastered and rather move more efficiently through the content that they need extra support with. Thirdly, actionable insights that move beyond data dumps or static dashboards that require a high amount of data literacy and instructional design literacy to interpret will allow teachers to use their time with students more effectively. Actionable insights enable things like just-in-time teaching so that teachers can have insights into areas that the whole class may have already mastered and be able to target their instruction on areas where the class needs extra support. Actionable insights can also provide information about individual students and help them understand when is appropriate to reach out, for what purpose, and in what ways. We also know that teachers have many competing demands as well. AI can relieve teachers of mundane tasks such as course management, grading multiple choice tests, tracking progress. Relieving some of this burden can ease critical capacity issues that enable the human interaction that teachers have with students to be more impactful. As researchers and developers, we have the opportunity and responsibility to provide evidence of what works, for whom, and why. The intended learning outcomes of AI-powered capabilities and solutions should be defined prior to building, and a theory of action based on empirical research should underpin development so that we can more easily measure and communicate how efficacious a solution is. But development of a portfolio of evidence, or what I refer to as an efficacy narrative, is much broader than evaluating the relationship between use and defined outcomes. It includes a whole host of evidence gathered throughout the research and development lifecycle, including who was involved in the development process, how was it tested, what were the models built. Together, that combined portfolio of evidence provides users the information they need to make informed adoption and implementation decisions. Similarly, Contextual data is critical to making appropriate inferences about efficacy, and it can add important color to engagement, usage, and performance data. For example, if we see a set of students continually disengaging, we may make inferences about their motivation that could be due simply to unreliable internet access. But lacking that context, we could be making inappropriate insights. Lastly, it's important that we transparently share information about the efficacy of AI-powered solutions, and not just in the academic journals that researchers typically publish in, but rather in formats that are both easily accessible and easily consumable by all users of a solution. AI for good can move beyond doing no harm and toward addressing critical issues like the digital divide, implicit bias, and differential efficacy. A couple of the principles that the labs follow when we're building for efficacy is to reduce bias in our data sets that are being used to train AI models in order to contribute to the development of equitable automated capabilities. We acknowledge that a limitation is that we'll never be able to achieve a truly representative sample, but by working to get closer to that and transparently communicating where we've gotten can build trust and enable equitable build. Second is to hire diverse teams so the perspectives of the individuals designing the solutions are representative of the individuals who will be using those solutions to combat inherent bias. And similarly, when we talk about the co-design process, it's important to engage in intentional recruitment practices so that we're recruiting partners from across user segments that reflect the backgrounds, demographics, values, beliefs, and experiences of our target end users. Certainly, informed consent is important so users understand how their data will be used, how it will be stored, and whether and when it will be destroyed. Having transparent guidelines about the security and how we're storing those data and how we're protecting them is critical as well. As I noted, measuring efficacy is important, but specifically measuring the differential efficacy of solutions among the subgroups of users it was designed for can help inform iterative improvement if we see that there is variability in outcomes among subgroups. The Agile process allows us to quickly and efficiently go back to users to co-design with them for iterative improvements to make sure they're receiving equitable benefits. And as I noted, transparent reporting is critical to ensure that users understand the efficacy of the solutions that they're engaging in so that they realize if the solution has been built for equity. Now that we've talked a little bit about the context and some critical principles, I'd like to introduce you to the AI labs at ETS. The ETS AI labs support all learners on their educational and workforce journeys by providing research-based, user-obsessed, and technology-enabled learning and assessment solutions. This is our mission, and now we'll dive a little bit into what we mean by research-based, user-obsessed, and technology-enabled. AI-based solutions built in the labs are based in empirical research. A research base allows us to promote development risks and fast failure because we're always learning. Prototypes that we build enable immediate user interactions so that we can conduct research in an ongoing way. And the studies that we conduct throughout the product development lifecycle enable the development of a portfolio of robust evidence that support adoption and implementation decisions. When we say research-based, it's best illustrated by a visual that Daniel Stokes presented in his book Pastor's Quadrant. In his book, he laid out a set of methods of research ranging from purely basic research with no application to purely applied research with no foundation in theory. But in the upper right-hand quadrant, you see that there is use-inspired research, which in his book, Stokes represents through Pasteur's work. He advanced basic science, but produced societal benefits, such as pasteurization to prevent illness and the rabies vaccine. In the labs, we're very curious about fundamental principles of automation and how it can assist users in meeting their goals. But we also have a strong desire to create useful solutions that will make their way into the hands of users. Our mission is to develop solutions that advance fundamental science and technology and have incredible societal benefit. I recognize for sure that this is a lofty goal, but I do believe we can reach it. One of the ways that we can reach these goals is through user obsession. Everything that we conduct in the labs is guided by user needs. All of our solutions are co-designed with a representative sample of our users. Users are partners and participants in research. They help us understand what their intended outcomes would be, what the evidence is that they would like to see that we've reached those outcomes, and how they want that evidence communicated. Once we have a prototype solution, it's continually tested with users so that their feedback can be continually implemented back into the solution and regular releases can be made. So we define user obsession in the labs as a deep, focused, and sustained commitment to our users. User-obsessed R&D embraces design thinking and includes user-centered design, but extends beyond those principles to testing, studying, and continual partnering. Even after a solution is being used at scale, it's important to continually partner with users. As we all know, the world is changing rapidly around us. And as the world changes, so don't user needs change. We have to make sure that we are continuing that research to track how user needs are evolving so that our solutions can evolve with their needs. Certainly, none of this is possible in the labs unless it's based in a modern technology strategy. Cutting-edge technology enables the powerful solutions that are built in the labs. We have dedicated technology teams embedded in our research lab teams to ensure that we have a true agile functioning team and that we can develop, iterate, and optimize together. Common stacks and architecture are used among different teams to enable innovation at scale. And a modern technology strategy is aligned with a core AI strategy in ETS. We are focused on an efficient delivery model, as I said, through the agile process, next generation infrastructure, cloud, automation, CI/CD, and integrated teams allowing for agile development. We're based on a forward-thinking foundation, flexible open frameworks, robust APIs, data architecture to enable advanced analytics, and the technology strategy drives innovation. We build natively digital capabilities, we focus on user experience, and we develop an intentional user data footprint that can enable intentional automation and the ability to measure the efficacy of solutions. To give you a quick introduction, ETS currently has 3 labs. The Natural Language Processing Lab focuses broadly on leveraging computational linguistic expertise to provide powerful NLP to our solutions. The lab provides automated content generation that moves beyond simply cloning items to scaling the content generation of the future. We enable assessment and scoring of language and behaviors on the features that users say are most critical to their progress. And teams in the lab offer targeted feedback on language that enables personalized learning at scale. In the Personalized Learning and Assessment Lab, we enable efficient and effective progress on a learner's unique educational journey through the development of automated environments, the provisioning of actionable insights, but then more importantly, closing the loop by offering impactful interventions that will support the insights that we've provided. The Language Learning Teaching and Assessment Lab leverages the capabilities that are developed in the NLP and PLA labs and applies those capabilities specifically to language learning space. The capabilities and solutions that are developed in the LLTA lab help language learners worldwide meet their language learning goals, help them advance in their academic and conversational language, and enable confident proficiency practice. The teams in the labs are working collaboratively on the development of AI-powered capabilities through user-centered design, experiments, and testing. Through the work in these agile teams, best practices and some pitfalls to avoid have emerged. I share these today as a starting point. The labs certainly don't have all the answers, and we're always looking for colleagues in the field to help add to our knowledge base. But I hope that some of our learnings might support some of your efforts. When beginning the development of AI-based solutions, I urge lab teams to consider all users in the value chain. Different applications of AI might support different users in unique ways. For example, consider a K-12 courseware solution. While the learner, as the end user, might benefit from a personalized learning path, let's say, their guardian might benefit from automated updates about progress the learner is making toward their defined goal. And the learner's teacher might need an automated management system that helps her communicate with the learner in a timely fashion. If the needs of only one of the users in the value chain was considered, important opportunities for the application of AI might be missed. We've also found it to be incredibly important to refer to the literature. There are many people in the K-12 education field who are working on similar problems as they relate to the application of AI. It's likely that someone has found at least a partial solution to your problem. I urge teams in the labs not to reinvent the wheel. Literature reviews, open source code can all help in different ways, whether it's to narrow their focus, give them a starting point to build from, or even help them identify a colleague in the field that they should reach out to for collaboration. Like I suggest that they refer to the literature and they refer to open source code, I also strongly recommend that they share their learnings, that they provide information in ways that are easily consumable, and that we enable open source code also so other researchers can learn from what we have built. One of the best practices that I'm most passionate about is pairing learning science with AI. I believe that AI in education should never be considered in isolation from the learning science it is enhancing. So in the labs, the method that we follow is that we first build a theory of action to understand the solution that we're working toward. On top of that theory of action, though, a cognitive learning model is built. The cognitive learning model includes specific nodes that previous research suggests, when used together, will influence the outcomes that are intended through the learning model. Then, on top of the learning model, teams identify where and how it is most appropriate to apply automation to enable efficiency, flexibility, and insights. One of the benefits of developing theories of action, cognitive learning models, and overlaying opportunities for AI on top of those learning models is that it gives us a starting point to engage with users to understand if these are the right areas where automation should be applied. In doing so, we're able to iterate and optimize in a way that we're not overbuilding, and we can test early and often. We've also found that it's incredibly important to select the right model. Sometimes the most appropriate model is not the most complex model. What might be considered a simple approach can provide meaningful insights. I typically suggest starting with a more simple model, evaluating those results, and building from there. Like the development of solutions, model building can be conducted in an agile way such that you don't overbuild unnecessarily. And importantly, the necessity of interpretability can't be overstated, either for the engineers or the users of the models. Interpretability can build trust among users who are engaging with developers to co-design AI. I also suggest that when building AI, particularly for MVPs or prototypes, it's important to weigh overly fine-tuned models with practicality. I ask our scientists and engineers to ask themselves, does gaining accuracy percentage really benefit the specific project enough to warrant the many experiments that gain required? Conducting these extra experiments can be costly in terms of time and in terms of time to getting a solution to a user. The more experiments that we're conducting, the less time we have to engage with users to understand whether we have met their needs and whether the accuracy is appropriate to the insight that they're trying to receive. Now, while it's true that I do caution against fine-tuning, it is important to run numerous experiments since there are so many variables impacting an algorithm's performance. There is a difference, though, between appropriately experimenting and overly fine-tuning a model. When conducting these experiments, it is very important that the experiments are tracked clearly, including their purposes and outcomes. By tracking experiments, it can help cross-team collaboration, but also enable transparency so there can be an evaluation of whether in fact teams are overly fine-tuning. And speaking of cross-team collaboration, it's critical to always make experiments reproducible. In order to reproduce experiments, this requires code versioning and code quality. Sometimes in the labs, I hear scientists and engineers refer to research code. I think that we can never be too sure of the code quality because in order to reproduce, research code is likely not going to suffice. It's so exciting to be in a space where we have the opportunity to responsibly improve the lives of teachers, students, their families, and all of their support systems, while also creating opportunity building trust among users, and working toward closing equity gaps. To move in this direction, though, we all need to think, talk, and collaborate more on responsible AI, what it is, how we build it, how we implement it, and that we get together and we continue to share best practices for achieving it. As I said, in the AI labs, we certainly don't have all of the answers. Like AI, the labs are in their infancy, but we are learning every day. I hope to learn from you all in the future, and I hope that today I've shared at least a little something that you can take with you to use in your efforts. Thank you very much for the time today to listen to an introduction to the ETS AI Research Labs. Talk with me about the principles that we follow when applying AI to K-12 education, and understanding what we mean when we say that we're developing research-based, user-obsessed, and technology-enabled solutions. I believe now there is some time for questions, and I look forward to engaging with you all. Thank you.